Hi everybody, Leanne here. I'm going to go over the problems for section 6. So that's chapter 4, section 6 or 4.6. We're doing the same problems we did in section 5, 1, 3, 4, and 7. So in number 1, we have to solve this multiplication problem in 3 different ways. And we're looking at the standard algorithm, also called the common method. We're looking at partial products. And then we're also going to look at how those methods are related. We're going to also look at sort of the expanded form that uses some of the properties that we looked at in the last couple sections. All right, so 96 times 8 using the standard traditional algorithm. We, of course, will end up with something that looks just like this. All right, so now if we look at the steps in the partial product, when we do the partial product, we're looking at and we're acknowledging the value of each place. So here we're looking at the units place, 6 times 8, and that's where we get our 48. But in the next step, we're looking at this 9, which is actually a 90, times this 8. And so 90 times 8 is 720, and we end up with 768. In the traditional common method or the standard algorithm, we're combining these two steps into one step. And so that's why it's a more efficient procedure. It's the combination of both of those steps. It's important for kids to learn the partial product multiplication so they really understand that it's sort of like not just magical that it works, or there's a rhyme and a reason for why it works. That's why the partial product method can be so powerful. All right, so then if we look at the expanded method using the properties of multiplication that we've looked at, we can think of 96 as 90 plus 6, and then we're multiplying 8 groups of that, which is multiplying 90 times 8 and 8 and 6 times 8. Our 90 times 8 is, of course, our 720, and our 6 times 8, of course, is our 48. So we end up with 768. So the steps in the partial product method and the expanded form, they directly relate to each other. They're disguised in the common method because they're really combined, but they're still in there. They're just disguised in that standard algorithm. So we essentially had 720 plus 40 plus 8. Okay, let's go to number 3. Number 3, we're doing a very similar thing. This time we're multiplying 237 times 43. This one, because we have a 3-digit times a 2-digit, we end up with quite a long expanded form. So stay with me here, everybody. Okay, so let's do, I'm going to go back and do a different color here. Here we go. All right, so using our standard traditional algorithm that you're all familiar with, we end up with 10,191. So there's a lot of what we call carrying, right, in this standard algorithm, but I just want us to make sure that if we're using that terminology, we're making sense of it for kids. What are we carrying? What is really happening when we're carrying? And it helps to see how that plays out in the partial product multiplication. So when we do 237 times 43, again, we're going to acknowledge each of our units and the value of each unit and write down basically all the partial products here. So 7 times 3 is 21. Then we would do this 3, but that's actually a 30 times 3 and get 90. Then we would do this 2 times that 3, but that's actually a 200 times 3 to get 600. So these 3 steps, the 600 plus the 90 plus the 21, are all combined right here into that first step in the standard algorithm. So they're disguised in there, but they're all together going to be within the 711. And then we go here, we have 40 times 7 is 280. 40 times 30 is 1200, and 40 times 200 is 8,000. And so then this partial product, if we add the sum of those 3 partial products, it's going to equal the 9,480. So again, these 3 partial products are disguised within that one step of the standard algorithm. And then when we add all of those partial products together, of course, we're going to get that same final product. All right, so then if we look at our expanded form, we're looking at 237 as 200 plus 30 plus 7, and then we're multiplying it times 43, so we're going to think of 43 as 40 plus 3. So this is a bunch of multiplication because we're going to have to multiply our 40 times each of these, and then we're going to have to multiply our 3 times each of these. So it ends up being quite long. So we have 200 plus 30 plus 7 times 40, and then we're going to add 200 plus 30 plus 7 times 3. So that's a 200 times 40. That's our 800 or 8,000. Let me get a different color. So that's our 8,000. Then we have our 30 times 40. That's our 1,200. Then our 7 times 40. That's our 280. Then our 200 times 3, that's our 600. Then our 30 times 3, that's our 90. And our 7 times 3, that's our 21. So I hope you see how slick that is, that the partial products show up in our expanded form. And if we're really careful, we can see how they're combined in and sort of disguised in our standard algorithm. So then, of course, we end up with all of those partial products added together to get the same final answer. All right, number 4. I think this is the big one here. Yeah, this is the big one. So when we multiply 37 times 26 by using the common method, we start the second line by writing a 0. And there's so many different terminologies that are used for this. Some teachers call that a placeholder. Some actually ask kids to skip that line. It's really important that we place a 0 there, and it's really important that we explain to kids why we do that and the meaning of that 0. So when we start multiplying 37 by 2, we're actually multiplying by 20. So let's go back to that problem. When we go to our second line here, and we're multiplying our 37 times this 2 in the standard algorithm, we call it a 2, right? When we're thinking in our head, but it's actually not a 2, it's a 20. And so by putting that 0 in that line, what we're doing is we're essentially acknowledging that that is a 20, or it's 2 groups of 10. So we've effectively now, by doing so, multiplied 37 by 10. So now we can focus on multiplying by 2. So by putting the 0 there, we don't have to think to ourselves, oh, that's actually a 20. We've put the 0 there, so now we can go back to effectively just multiplying by 2, like we would in the regular standard algorithm. All right, and the last one, number 7, we're going to use the partial products and the common method to calculate 27 times 28. Then we are going to draw an array, a multiplication array for this, and then we're going to correspond all of these pieces together and also do an expanded form. So this is a big one. Basically, we're looking at all the different methods that we would use, including a math diagram for multiplying 2 numbers that are 2 digits. All right, so 28 times 27. So we end up, you can see that I started with the partial products multiplication here. So I did 8 times 7, I have my 56. Then I did my 20 times 7, there's my 140. Then I did my 20 times 8, there's my 160. And then I did my 20 times 20, there's my 400. You could make an argument that the partial products multiplication is just as efficient and quick as the standard algorithm. Yes, I agree, you could make that argument, but both of these methods are in the standards that we're required to teach. So it's important that we understand that. Just to remember, these 2 steps in the partial products multiplication are combined into one in the standard algorithm, and these 2 steps are combined into the second step. All right, now if we were to draw a multiplication array for this, we have to have a side of our rectangle that is 20 and 8, and the other side of our rectangle that's just 20 and 7. So then we end up with, we can see those 4 partial products so nicely. So we have our 20 times 20, so there it is, our 400. Then we have our 20 groups of 8, because the area of this section is 20 by 8. And there it is, 160. Then we have this area, 20 times 7. Shows up nicely here. And then our 8 times 7, and it shows up nicely here. You could also look at this. So this right here is what it would look like if we wanted a math diagram to reinforce our partial products multiplication. If we wanted to show a math diagram to reinforce our traditional algorithm, then we would want to show a 28 times 20 and 7, because what we're essentially doing here is when we multiply 28 times 20, we get this row. So this section is this row of our standard algorithm, and then our 28 times 7 is that section of the standard algorithm. So this math diagram supports the standard algorithm. This other math diagram that we just talked about supports the partial product multiplication. All right, last part. Let's look at the expanded form. So we're going to think of 28 as 20 plus 8, and we're going to think of 27 as 20 plus 7. So we're multiplying 20 times 20 plus 7, and then we're also going to multiply, so here, that makes sense, and now we're going to multiply 8 times 20 plus 7, because we're going to be using our distributive property knowledge here. When we do so, we have 20 groups of 20 and 20 groups of 7, 8 groups of 20 and 8 groups of 7. So we end up with all of our partial products showing up again in that expanded form, 400 plus 140 plus 160 plus 56, for our grand total still, of course, at 756. All right, hopefully that helps. Thanks for listening, everybody.